Hello students, today I am going to discuss a very important topic in the chapter of column, that is middle third rule. Middle third rule is also known as core of section. Now what is the significance of the core of section? The significance of core of section is we have to find out a particular section in such a way that if we apply load within the core of the section, within that particular section, then the column will not be under tensile forces, will not be under tension. Now for this, I have taken one rectangular section whose breadth is B and depth is D, and these are the two axes, x-axis and y-axis. Now a load P is applied parallel to the y-axis at a distance of Ex from the y-axis. So this P load is known as eccentric load and Ex is eccentricity. Now we know already condition for no tension in a column is E less or equal to Z upon A, where Z is the section modulus and A is the area of cross section. Here the load is acting parallel to y-axis, so Ex should be less or equal to Zyy divided by A. Zyy is the section modulus along y-axis. This should be is equal to Iyy, that is I moment of inertia about the y-axis divided by y. So moment of inertia of a rectangular plate about the y-axis is dB cube by 12 according to our figure, divided by y. Here y should be b upon 2. So Zyy is coming dB square upon 6. So hence Ex, that is less or equal to Zyy divided by A. I am putting the values of Zyy as dB square by 6, dB square by 6 divided by BD. It becomes B upon 6. So ultimately I am getting Ex less or equal to B upon 6. So this distance is B upon 6. See, again another load, if I put on the left side of the y-axis, and same Ex is the eccentricity, P is again acting as eccentric load, then similarly in a exactly same fashion I'll get Ex less or equal to B upon 6. So that means this distance B upon 6, this is B upon 6, this is B upon 6. So the total distance along x-axis between which if load is applied between this distance, then there will be no tension in the column. So this distance, total distance is Ex plus Ex, it is B upon 3. So these are the 2 points I have taken along x-axis. Between these 2 points, if we apply load, then there will be no tension. Now see, this is a load P, again is an eccentric load acting parallel to x-axis at a distance of Ey from the x-axis. Now here same, the Ey will be less or equal to Zxx divided by A. Zxx divided by A. But Zxx is the section modulus about z-axis. So here I have found Ixx divided by y. Now Ixx, that is the moment of inertia about x-axis, it will be b d cube upon 12 divided by y. Y is now d upon 2. So ultimately I am getting Zxx is equal to bd square upon 6. So Ey here, if we put the values of Zxx and the area A, then Ey is less or equal to d upon 6. So this distance is d upon 6. Now second load acting Below the y-axis, again at a distance of ey from the x-axis, eccentricity is ey, P is the eccentric load. I'll get again in the similar way ey is less than equal to d upon 6 by putting the values of z, x, s and a. So this two distance ey is d upon 6, ey is d upon 6. So total distance from this point to this point is again d upon 6 plus d upon 6 is equal to d upon 3. So I have taken 2 points here. One point is this, one point is this. So the distance between these 2 points is d upon 3. So I have taken, so total distance along y-axis between which if the load is applied, then there will be no tension, Ey plus Ey is equal to d upon 3. So I have got, this is a core of a section. This is called core of a section, means within this core of a section, if we apply load, then the column will not be under tension. And this is the middle third rule, which is applied in order to design a column. If you find my video good, then you please subscribe it, share it, and like it. Thank you.